like that.
In Chapter 16. In this chapter, we'll finish building our snake game. In Chapter 16, we set up the playing area and covered how the game would work in general. Now we'll create the objects that represent the snake and apple in the game, and we'll program a keyboard event handler so that the player can control the snake with the arrow keys. Finally, we'll look at the complete code listing for the program. As we create the snake and apple objects for this game, we'll use the object-oriented programming techniques we learned in Chapter 12 to create constructors and methods for each object. Both our snake and apple objects will rely on a more basic block object, which we'll use to represent one block on the game board grid. Let's start by building a constructor for that simple block object. In this section, we'll define a block constructor that will create objects that represent individual blocks on our invisible game grid. Each block will have the property COL, short for column and row, which will store the location of that particular block on the grid. Figure 17:1 shows this grid with some of the columns and rows numbered, although this grid won't actually appear on the screen. Our game is designed so that the apple and the snake segments will always line up with it. Figure 17:1. th. E column and row numbers used by the block constructor. In figure 17:1, the block containing the green apple is at column 10, row 10. th. E head of the snake to the left of the apple is at column 8, row 10. Erase the code for the block constructor. Var block equals function col row. This.col equals col. This.row equals row. Column and row values are passed into the block constructor as arguments and saved in the col and row properties of the new object. Now we can use this constructor to create an object representing a particular block on the game grid. For example, erase how we'd create an object that represents the block in column 5, row 5. Var sample block equals new block 5. Figure 17:2. Calculating the values for drawing a square. Draw circle. Draw square. Circle instead of a square. Block.prototype. Draw circle equals function color var center x equals this.col block size /2 var center y equals this.row block size /2 ctx.fill style equals color circle center x center y block size /2 true. First we calculate the location of the circle's center by creating two new variables, center x and center y. As before, we multiply the col and row properties by block size. But this time we also have to add block size /2. Because we need the pixel coordinates for the circle's center, which is in the middle of a block as shown in figure 17:3. We set the context fill style to the color argument as in draw square and then call our trusty circle function, passing center x and center y for the x and y coordinates, block size /2 for the radius. And true to tell the function to fill the circle. This is the same circle function we defined in chapter 14, so we'll have to include the definition for that function once again in this program as you can see in the final code listing. Erase how we could draw a circle in column 4, row 3. Var sample circle equals new block 3. Sample circle dot draw circle light green. Figure 17:3 shows the circle, with the calculations for the center point and radius. Figure 17 to 3. Calculating the values for drawing a circle and the snake's head are in the same location, that means the snake has eaten the apple. On the other hand, if the snake's head and tail are in the same location, then the snake has collided with itself. To make it easier to compare block locations, we'll add a method, equal, to the block constructor prototype. When we call equal on one block object and pass another object as an argument, it will return true if they are in the same location and false if not. Erase the code. Block.prototype dot equal equals function other block. Return this .col equals other block.col this .row equals other block.row. This method is pretty straightforward if the two blocks this and other block have the same col and row properties, that is, if this .col is equal to other block.col and this .row is equal to other block.row. Then they are in the same place, and the method returns true. For example, let's create two new blocks called apple and head and see if they are in the same location. Var apple equals new block2, 5. Var head equals new block3, 5. Head dot equal apple. False. Although apple and head have the same row property 5, their col properties are different. If we set the head to a new block object one column to the left, now the method will tell us that the two objects are in the same location. Head equals new block2, 5. Head dot equal apple. True. Note that it doesn't make any difference whether we write head dot equal apple or apple dot equal head. In both cases we're making the same comparison. We'll use the equal method later to check whether the snake has eaten the apple or collided with itself. Now we'll create the snake. We'll store the snake's position as an array called segments, which will contain a series of block objects. To move the snake, we'll add a new block to the beginning of the segments array and remove the block at the end of the array. The first element of the segments array will represent the head of the snake. Var snake equals function. This dot segments equals new block7, 5, new block6, 5, new block5, 5. This dot direction equals right. This dot next direction equals right. Defining the snake segments. The segments property is an array of block objects that each represent a segment of the snake's body. When we start the game, this array will contain 3 blocks at 7, 5, 6, 5, and 5, 5. Figure 174 shows these initial 3 segments of the snake. Figure 17 to 4. Th. E initial blocks that make up the snake. Setting the direction of movement. The direction property it stores the current direction of the snake. OU. Our constructor also adds the next direction property ed, which stores the direction in which the snake will move for the next animation step. Th. Is property will be updated by our keydown event handler when the player presses an arrow key. See adding the keydown event handler. FO. R now, the constructor sets both of these properties to right. So at the beginning of the game our snake will move to the right. Segments. Draw square method we created earlier on each block. This will draw a square for each segment of the snake. Snake.prototype .draw equals function. For var I equals 0, I. Length I. This dot segment C dot draw square blue. The draw method uses a for loop to operate on each block object in the segments array. Each time around the loop, this code takes the current segment this dot segment C and calls draw square blue on it, which draws a blue square in the corresponding block. If you want to test out the draw method, you can run the following code, which creates a new object using the snake constructor and calls its draw method. Var snake equals new snake. Snake.draw. Well, create a move method to move the snake one block in its current direction. To move the snake, we add a new head segment by adding a new block object to the beginning of the segments array and then remove the tail segment from the end of the segments array. The move method will also call a method, check collision, to see whether the new head has collided with the rest of the snake or with the wall, and whether the new head has eaten the apple. If the new head has collided with the body or the wall, we end the game by calling the game over function we created in chapter 16. If the snake has eaten the apple, we increase the score and move the apple to a new location. Move. Snake.prototype. .move equals function. Var head equals this dot segments 0. Var new head. This dot direction equals this dot next direction. If this dot direction equals right new head equals new blockhead dot col 1 head dot row. Else if this dot direction equals down new head equals new blockhead dot col head dot row 1. Else if this dot direction equals left new head equals new blockhead dot col 1 head dot row. Else if this dot direction equals up new head equals new blockhead dot col head dot row 1. If this dot check collision wed, game over. Return. This dot segments unshift new head. If new head dot equal apple dot position score apple dot move. Else this dot segments hop. Let's walk through this method piece by piece. Creating a new head, we save the first element of the this dot segments array in the variable head. We'll refer to this first segment of the snake many times in this method, so using this variable will save us some typing and make the code a bit easier to read. Now, instead of repeating this dot segments 0 over and over again, we can just type head. And we create the variable new head, which we'll use to store the block representing the new head of the snake which we're about to add. And we set this dot direction equal to this dot next direction, which updates the direction of the snake's movement to match the most recently pressed arrow key. We'll see how this works in more detail when we look at the key down event handler. Direction and next direction. The snake's direction property will be updated exactly once for each step in the animation, since the move method is called once per animation step. The next direction property, on the other hand, will be updated anytime the player presses an arrow key, so if they press the keys really fast. This property could theoretically change multiple times per animation step. By keeping these two properties separate, we make sure the snake can't turn back on itself if the player presses two arrow keys very quickly between two steps in the animation. Beginning it, we use a chain of if-else statements to determine the snake's direction. In each case, we create a new head for the snake and save it in the variable new head. Depending on the direction of movement, we add or subtract one from the row or column of the existing head to place this new head directly next to the old one, either right, left, up, or down depending on the snake's direction of movement. For example, figure 17 to 5 shows how the new head is added to the snake when this dot next direction is set to down. Figure 17 to 5. Creating new head when this dot next direction is down. Checking for collisions and adding the head that we call the check collision method to find out whether the snake has collided with a wall or with itself. I'll see the code for this method in a moment, but as you might guess, this method will return true if the snake has collided with something. If that happens, the body of the if statement calls the game over function to end the game and print game over on the canvas. The return keyword that follows the call to game over exits the move method early, skipping any code that comes after it. You reach the return keyword only if check collision returns true. So if the snake hasn't collided with anything, we execute the rest of the method. As long as the snake hasn't collided with something, we add the new head to the front of the snake it. By using unshift to add new head to the beginning of the segments array. For more about how the unshift method works on arrays, see adding elements to an array. Eating the apple edit, we use the equal method to compare new head and apple dot position. If the two blocks are in the same location, the equal method will return true, which means that the snake has eaten the apple. If the snake has eaten the apple, we increase the score and then call move on the apple to move it to a new location. If the snake has not eaten the apple, we call pop on this dot segments. This removes the snake's tail while keeping the snake the same size since move already added a segment to the snake's head. When the snake eats an apple, it grows by one segment because we add a segment to its head. We haven't defined apple yet, so this method won't fully work in its current form. If you want to test it out, you can delete the whole if-else statement and replace it with this line. This dot segments. Pop. Then all you need to do is define the check collision method, which we'll do next. Detection, a very common step in game mechanics, is often one of the more complex aspects of game programming. Fortunately, it's relatively straightforward in our snake game. We care about two types of collisions in our snake game: collisions with the wall and collisions with the snake itself. A wall collision happens if the snake hits a wall. The snake can collide with itself if you turn the head so that it runs into the body. At the start of the game, the snake is too short to collide with itself, but after eating a few apples, it can. Here is the check collision method. Snake.prototype .check collision equals function head var left collision equals head.col equals 0 var top collision equals head.row equals 0 var right collision equals head.col equals with thin blocks 1 var bottom collision equals head.row equals high tin blocks 1 var wall collision equals left collision top collision right collision bottom collision var self collision equals false. For var I equals 0, I length I. If head dot equal this dot segment C, self collision equals true. Return wall collision self-collision. Checking for wall collisions that we create the variable left collision and set it to the value of head.col equals 0. This variable will be true if the snake collides with the left wall, that is, when it is in column 0. Similarly, the variable top collision in the next line checks the row of the snake's head to see if it has run into the top wall. After that, we check for a collision with the right wall by checking whether the column value of the head is equal to width in blocks, 1. Since width in blocks is set to 40, this checks whether the head is in column 39, which corresponds to the right wall, as you can see back in figure 17:1. T. And we do the same thing for bottom collision. Checking whether the head's row property is equal to height in blocks, 1. We determine whether the snake has collided with a wall by checking to see if left collision or top collision or right collision or bottom collision is true. Using the OR operator, W. Save the Boolean result in the variable wall collision. Checking for self-collisions to determine whether the snake has collided with itself, we create a variable called self-collision and initially set it to false. Then we use a for loop to loop through all the segments of the snake to determine whether the new head is in the same place as any segment, using head.equal_this.segment_c. The head and all of the other segments are blocks, so we can use the equal method that we defined for block objects to see whether they are in the same place. If we find that any of the snake's segments are in the same place as the new head, we know that the snake has collided with itself, and we set self-collision to true. Finally, we return wall collision self-collision, which will be true if the snake has collided with either the wall or itself. Next, we'll write the code that lets the player set the snake's direction using the keyboard. We'll add a key down event handler to detect when an arrow key has been pressed, and we'll set the snake's direction to match that key. Bar directions equals 37 left, 38 up, 39 right, 40 down, body, dot key down, function, event, bar new direction, equals directions, event.keycode, if new direction, equals undefined, snake.setDirection new direction. And we create an object to convert the arrow key codes into strings indicating the direction they represent. This object is quite similar to the key actions object we used in reacting to the keyboard. And we attach an event handler to the key down event on the body element. This handler will be called when the user presses a key as long as they've clicked inside the web page first. This handler first converts the event's key code into a direction string, and then it saves the string in the variable new direction. If the key code is not 37, 38, 39, or 40, the key codes for the arrow keys we care about, directions event.keycode, will be undefined. And we check to see if new direction is not equal to undefined. If it's not undefined, we call the setDirection method on the snake, passing the new direction string. Because there is no else case in this if statement, if new direction is undefined, then we just ignore the key press. This code won't work yet because we haven't defined the setDirection method on the snake. Let's do that now. SetDirection uses it to update the snake's direction. This method also prevents the player from making turns that would have the snake immediately run into itself. For example, if the snake is moving right, and then it suddenly turns left without moving up or down to get out of its own way, it will collide with itself. We'll call these illegal turns because we do not want to allow the player to make them. For example, Figure 17 to 6 shows the valid directions and the one illegal direction when the snake is moving right. Figure 17 to 6. BA. Let new directions based on the current direction. The set direction method checks whether the player is trying to make an illegal turn. If they are, the method uses return to end early, otherwise, it updates the next direction property on the snake object. Erase the code for the set direction method. Snake.prototype .set direction equals function new direction. If this dot direction equals up new direction equals down return. Else if this dot direction equals right new direction equals left return. Else if this dot direction equals down new direction equals up return. Else if this dot direction equals left new direction equals right return. This dot next direction equals new direction. The if-else statement it has 4 parts to deal with the 4 illegal turns we want to prevent. First part says that if the snake is moving up, this dot direction is up, and the player presses the down arrow, new direction is down. We should exit the method early with return. Other parts of the statement deal with the other illegal turns in the same way. The set direction method will reach the final line only if new direction is a valid new direction. Otherwise, one of the return statements will stop the method. If new direction is allowed, we set it as the snake's next direction property, ed. In this game, we'll represent the apple as an object with 3 components: a position property, which holds the apple's position as a block object, a draw method, which we'll use to draw the apple, and a move method, which we'll use to give the apple a new position once it's been eaten by the snake. Position var apple equals function this dot position equals new block10 10. This creates a new block object in column 10, row 10, and assigns it to the apple's position property. We'll use this constructor to create an apple object at the beginning of the game. Draw apple.prototype .draw equals function this dot position .draw circle lime green. The apple's draw method is very simple, as all the hard work is done by the draw circle method, created in adding the draw circle method. To draw the apple, we simply call the draw circle method on the apple's position property, passing the color lime green, to tell it to draw a green circle in the given block. To test out drawing the apple, run the following code. Var apple equals new apple. Apple.draw. Move the canvas other than the border. We'll call this method whenever the snake eats the apple so that the apple reappears in a new location. Apple.prototype. .move equals function var random col equals math.floor math .random with thin blocks 2 1 var random row equals math.floor math dot random height in blocks 2 1. This dot position equals new block random col random row, and we create the variables random col and random row. These variables will be set to a random column and row value within the playable area. As you saw in figure 17:1, the columns and rows for the playable area range from 1 to 38, so we need to pick 2 random numbers in that range. To generate these random numbers, we can call math.floor math.random38, which gives us a random number from 0 to 37, and then add 1 to the result to get a number between 1 and 38. For more about how math.floor and math.random work, see decision maker. This is exactly what we do it to create our random column value, but instead of writing 38, we write width in blocks 2 t. This means that if we later change the size of the game, we won't also have to change this code. W. E do the same thing to get a random row value, using math.floor math.random height in blocks 2 1. Finally, and we create a new block object with our random column and row values and save this block in this dot position. This means that the position of the apple will be updated to a new random location somewhere within the playing area. You can test out the move method like this. Var apple equals new apple. Apple.move. Apple.draw. Our full code for the game contains almost 200 lines of JavaScript. After we assemble the whole thing, it looks like this. / setup canvas. Var canvas equals document dot get element viewed canvas var ctx equals canvas dot get context 2d / get the width and height from the canvas element var width equals canvas width var height equals canvas height / work out the width and height in blocks var block size equals 10 var width in blocks equals width / block size var height in blocks equals height / block size / set score to 0 var score equals 0 / draw the border var draw border equals function ctx.fill style equals gray ctx.fill rect 0 width block size ctx.fill rect 0 height block size width block size ctx.fill rect 0 block size height ctx.fill rect width block size 0 block size height / draw the score in the top left corner var draw score equals function ctx.font equals 20px courier ctx.fill style equals black ctx.text align equals left ctx.text baseline equals top ctx.fill text score block size / clear the interval and display game over text bar game over equals function clear interval intervalid ctx.font equals 60px courier. ctx.fillStyle equals black. ctx.textAlign equals center. ctx.textBaseline equals middle. ctx.fillText game over. Width /2, height /2. / draw a circle using the function from chapter 14. Bar circle equals function x, y, radius, fill circle. ctx.begin path. ctx.arcs, y, radius, 0, math.pi. 2, false. If fill circle. ctx.fill. Else. ctx.stroke. / the block constructor. Bar block equals function col row. This dot col equals col. This dot row equals row. / draw a square at the block's location block dot prototype. Dot draw square equals function color. Bar x equals this dot col. Block size. Bar y equals this dot row. Block size. ctx.fillStyle equals color. / check if this block is in the same location as another block dot prototype. Dot equal equals function other block. Return this dot col equals other block dot col. This dot row equals other block dot row. / the snake constructor. Bar snake equals function this dot segments equals new block 5, new block 6, 5, new block 5. This dot direction equals right. This dot next direction equals right. / draw a square for each segment of the snake's body snake dot prototype. Dot draw equals function for bar I equals 0, I. Length I. This dot segment C dot draw square blue. / create a new head and add it to the beginning of. / the snake to move the snake in its current direction snake dot prototype. Dot move equals function var head equals this dot segments 0. Var new head. This dot direction equals this dot next direction. If this dot direction equals right. New head equals new block head dot col. 1. Head dot row. Else if this dot direction equals down. New head equals new block head dot col. Head dot row. 1. Else if this dot direction equals left. New head equals new block head dot col. 1. head dot row.
เป็นสิบตรงขวา
Else if this dot direction equals 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 up
เอาดี
new head equals new block head dot col head dot row
สเกล
1. If this dot check collision wed,
Have you
game over.
have
Return. This dot segment
yourself no
unshift. New head. If new head dot equal apple dot position. Score. Apple dot move. Else. This dot segments dot pop. / check if the snake's new head has collided with the wall or itself snake dot prototype. Dot check collision
no
equals function
have you
Head.
check
bar left collision
no
equals head dot col equals 0 bar top collision equals head dot row equals 0 bar right collision equals head dot col equals with thin blocks 1 bar bottom collision equals head dot row equals high tin blocks
practical
One.
experience to advise me
bar wall collision
practical
equals left collision
experience
top collision right collision
advise me
bottom collision
No, you don't rest. Girafas. Wait a minute. What's it?